Hi everyone, today we are going to solve a very popular LeetCode problem that you will encounter in interviews. This problem is called Kth Largest Element in an Array, and this problem is tagged as a medium difficulty problem, and we will be solving it in C++ with a focus on efficiency. By the end of this video, you will have a clear understanding of how to approach this problem and why use a certain data structure to optimize it. We will implement the working solution in C++. So without wasting any time, let's get started. Let's start by understanding the problem requirement. The problem is asking us to find the kth largest element in an unsorted array. Now there are few things to clarify. We are not looking for the kth distinct largest element. What that means is if the elements are repeated in an array, we will count them separately. Let me give you an example. For example, let's say we are given this array and we need to find the second largest element. So in our case, the second largest element would be 10, not 9. Because there are two 9 and we are not looking for distinct element, we are just looking for the second largest. So that would be 10. And we need to focus on an efficient solution, ideally without sorting the entire array. Because sorting an array can take n log of n time, which can be slow for large arrays. Here is a quick example to make sure we understand the problem. Suppose we are given this array and k is 2, which means we are looking for the second largest element. After sorting this array, it would look like this, and our second largest element would be 5. But remember, to solve this problem, we are not allowed to use sorting. To solve this efficiently, we will use a min heap data structure, which is also known as priority queues in C++. But the question is, why use min heap? Let's break it down. So to solve this problem, we only need to track the kth largest element of array, which are 5, 6 and 4 in this case, since k is 3. With min heap, we can easily remove the smallest element from the group, and whenever the size of min heap exceeded the k, we can easily remove the smallest element from the group whenever the size of the min heap exceeded k. In this way, we will only hold the top k elements. And the root of min heap, which is the smallest element in the top k group, will naturally be the kth largest element. So as we go through the array, we will push each element to our min heap. If the heap size exceeds k, which in this case is 3, we will remove the smallest element, which will be the root of the heap. And once we go through the whole array, the root of our heap will be our answer. So our first element is 3. We will add it to our heap and then check the size. Current size is 1 and the k value is 3, which is less than 3. So we will go to the next element, which is 2. So current size of heap is 2, but which is less than k. So we will go to the third element, which is 1. So we will add this also to our heap. Still in our min heap, there are 3 elements which is not greater than the value of k. So we will go to our fourth element, which is 5. So we will add this to our min heap. Now our heap size is 4, but the value of k is 3. So we will remove the smallest element, which in our case is 1. So we will remove 1. And next we will go to the next element, which is 6. We will add it to our heap, min heap. And now the size of min heap is 4, which is greater than k. So we will again remove the smallest element. So currently in our min heap, the smallest element will be 2. So we'll remove this. And now we'll go to our last element, which is 4. We will add it to our min heap. And now the size of min heap is 4. It's still greater than k. So we will again remove the smallest element, which is 3. Once we go through the whole array, the root of our heap will be our answer, which is 4, because that is the smallest number. Let's quickly talk about time complexity to see why this approach is efficient. Adding an element to a min heap takes log of k time. Since we are doing this for each element in the array, the overall time complexity will become n log of k, where n is the number of elements in an array. This is much better than n log of n for sorting, especially if k is much smaller than n. Alright, now it's time to start coding. Let's go our solution step by step. So currently we have a function called find kth largest that takes a vector nums and an integer k. First we need to define a priority queue. In C++, a priority queue by default is max heap. So to specify a min heap, we will use comparison function object. Next, we will iterate through each element in the vector, and for each element we add it to the heap. If the size of heap exceeds k, we remove the smallest element to keep only the largest k elements in the heap. After the loop, the top of the heap will be the kth largest element. So we will return it. And that's it. Now let's try to run this code. So all the test cases are okay. And you can see this code works really well. It's a very efficient solution for our problem. I will also attach the code for this problem in the description box. Now let's quickly summarize. We solved the kth largest element problem using a min heap, making our solution efficient with a time complexity of n log of k. By using a min heap, we could maintain the top k largest element and efficiently find the kth largest without sorting the entire array. This approach is optimal for large dataset where sorting is too slow. And that's it for today's tutorial. I hope you found this video helpful and that you now feel confident tackling this problem on your own. If you enjoyed this tutorial, please give it a thumbs up, subscribe for more coding tutorials, and let me know in the comments if there is a problem you would like to see explained. Thank you so much for watching, and I will see you in the next one.